I'm Pedro Dinesio. I'm a climate scientist and a professor at the University of Colorado. I'm interested in global climate and predicting climate, particularly natural variations that come from the Pacific, which we call El Niño and La Niña. And what a great day to have Michelle Leroux from NOAA's Climate Prediction Center, who's joining us to talk about how we do climate prediction and how we predict El Niño and La Niña. Michelle is a physical scientist at the Climate Prediction Center, where she's focused on understanding and improving climate predictions from 2 weeks to a year, so beyond the limit of weather prediction, of predicting weather. Michelle has a bachelor's degree in environmental science from the University of Virginia and a master's degree in atmospheric science from Colorado State University. Her main responsibility at the Climate Prediction Center is coordinating a team that updates the official status and forecast of the El Niño Southern Oscillation, ENSO, which is our fancy, more scientific way of calling El Niño and La Niña and their global influence on climate. So what a great day to talk with Michelle, because NOAA just released the update for the coming month.
Yes.
For the status of El Niño. So we have Michelle here just to talk about a lot of things about the current status, but also how we do prediction of El Niño and La Niña, because this is still, I would argue, an area of active research. So research and operations meet. So, and I think this year is a great example of how we need all that research to make better predictions. So welcome, Michelle. Thanks for joining us.
Yeah, no, thanks for having me here. And Pedro is too modest. He is also a leading ENSO expert in the field, a really prolific researcher on ENSO topics. So it's really a pleasure to be here and interacting with you, Pedro. It also is great timing because Pedro contacted me, I think, a couple weeks ago, and he had no idea that we were going to be issuing our ENSO update today. And it is an interesting update because we last month declared the end of La Niña, and we had 3 back-to-back La Niña winters, which was interesting in its own right. And today, NOAA updated its ENSO forecast, and we are issuing an El Niño watch, which basically means that conditions are favorable for the onset of El Niño within the next 6 months. However, if you dig a little deeper into our discussion, what you'll find is that this is a bit of a pivot for us. We had elevated chances of El Niño later in the year last month. They were about 60-65% at their peak. This month, our peak probabilities for this upcoming winter are about 80%, which is quite a jump, meaning that the team that puts together these predictions is a lot more confident that we're potentially going to see the development of El Niño. However, and there is recent precedent for this, is that making forecasts in the spring is very, very tricky. And that's because at this time, the model forecasts tend to have a minimum in accuracy or skill, meaning that it's a little bit like forecasting with blurry glasses. And it's sometimes hard to see because you can have very small perturbations that lead to drastic changes in the forecast this time of year. And we emerge from it, I don't know, Pedro, everyone's always like, which month do you emerge? And I'm like, June, maybe? What's your opinion?
Thanks for the question. I would think it's probably the aggregated effect of everything that happens in boreal summer. So June, July, sometimes May can have an effect, but June, July for sure are the months where things are defined.
Right.
But the fact that some models are so confident this time of the year,
yes,
it's intriguing. So it's a bit of a deja vu of 2014,
Yes.
when everyone was expecting a big El Nino very early on in the year because we had that big westerly wind burst. It was earlier, right? I recall it was February of 2014. There was, or March. There was a massive westerly wind burst, which we all know those tend to affect the ocean in the equatorial Pacific and warm the far eastern equatorial Pacific. And sometimes we think that can kick an El Nino. What are your thoughts on that? Is this a deja vu, a replay of 2014? Or...
So I'm very mindful of that. And 2014 was also interesting because we do these operational forecasts every month, meaning that, 2014, I remember at that time that some very prominent voices in the research community were basically saying this is going to be the next 97, 98. And for those that don't know, 97, 98 is like the benchmark El Nino of the, of the 21st century, where, we saw very canonical effects and it was a very large El Nino. And we haven't really seen one quite of that nature. 2015, 16 rivaled that, but it was a little different in terms of its characteristics. So in 2014, we were thinking, or a lot of researchers were thinking, that this is it. This is going to be the next 97, 98. And we were issuing forecasts that were more conservative. I remember in March of April 2014 thinking, we have a long way to go here. It's April or March or whatever it was. And we still don't know the ultimate intensity. So I remember distinctly sitting here a little frustrated because I was like, I don't know if we can confidently say that this is going to rival that event. And 2014 was a great and very instructive experience because it did not. It could have gone either way. Certainly there was enough energy in the system that it could have pivoted into a major event, and it did the year after, but it just didn't do it at that time. And I thought it was really instructive. It was a good forecasting moment for everyone. I sometimes wonder, like right now, of course, there's anxiety whether we're another 2014 like event, but I also think it's important to realize there are precursors there, and they are starting to get amped up here. So in 2014, we had about an 80% chance at the end of the year of an El Nino formation. And that's roughly where we are now. So you know what? That might have been the right call in 2014. It just so happened that we ended up more in that 20%. And that will happen because the uncertainty behind seasonal prediction and ENSO prediction is so large. So it will be really interesting to see where this goes, because I think a lot of people are worried about false alarm, that is an El Nino prediction that doesn't happen. But we have to remember that the low skill and the low accuracy can work both ways. You have to watch out for false negatives as well. So it's possible that the system is transitioning in a major way here, and we need to make sure that we're attentive to that, and we're letting the public know that they need to be watchful and mindful that we could have an event by the end of the year that's quite significant.
So many things to talk about with what you just said about uncertainty and how we use it. But I was wondering if we could look into the update and maybe discuss some of these differences that are included in the update and
yeah, like distinctly, why is 2000 like now in 2014, like where are there similarities and where are there some differences? Can I share my screen? Because I actually have one graphic I want to share.
Absolutely, yeah.
Okay, let's see if this works. All right. Okay.
This is just a reminder for everyone out there. I see there are some people online. You're welcome to ask questions on the chat on the YouTube channel.
Yeah, definitely. I'm curious what folks are thinking. So this is the March average. We're obviously in the middle of April, so we don't have the full April average for 2023 yet. But this is one plot that we were looking at when the team of forecasters was sitting down making their forecasts. And we have an oceanographer in-house named Kai-Hong Win, and she shared this plot with us, which I thought was pretty interesting. And what it's showing is the depth of the 20 degrees C isotherm. So it's a measure of heat in the ocean, and El Nino, of course, is heat in the ocean. And ultimately, we want to see these reds expand, these red shading, and that provides the seeds for our El Nino events. This is all occurring in the subsurface ocean. And at this time in March 2014, we saw what's called a downwelling Kelvin wave. And essentially, it's a big slug of warm water in the subsurface that pushes eastward. And it starts over here in the Western Pacific, and then it takes about 2 to 3 months to actually navigate across the entire Pacific. But once it hits coastal South America, it can basically manifest at the surface and really start heating things up. So we were watching this in 2014. This was a lot of heat. And so probabilities for El Nino were growing because it was potentially going to do exactly that, surface and then start the El Nino event. But one interesting thing is right behind it in the Western Pacific, we actually saw some below average temperatures. And that ended up also pushing to the east. So after this went through, and it did, we then saw what we call an upwelling phase of a Kelvin wave, and that navigated all the way across the tropical Pacific and cooled things down, much more so than the models were anticipating. And if you look right now, this is March 2023, what we're seeing here, by the way, I should mention all these panels are just showing different ocean reanalysis because ocean reanalysis takes into account observations and models. And so you can get little differences depending on which observational analysis you're looking at. But this is the mean of all those analyses. So in principle, the most reliable image of what we can see right now. And so right now we're getting another downwelling Kelvin wave. It's not quite as potent in terms of its peak amplitude, at least not at this point. But in the Western Pacific, there's still a lot of heat back there. And while I'm not showing it, as we speak, there's a westerly wind event occurring right now near the dateline. This westerly wind event, we had another one about a month ago, which was further to the west. And this one's shifted further to the east. So it's occurring right basically on top of the dateline. Dateline's right here. Meaning we're starting to see essentially the movement of surface winds to help keep pushing the heat eastward across the tropical Pacific Ocean. And that is a precursor. So when you're looking for seeds of big El Nino events, or really any El Nino events, you need warmth and you need these westerly wind bursts to recur. They can't just stop. As Pedro and I just talked about, we were talking about the spring predictability barrier and how we feel like June, July is when we kind of start emerging from it. In part, that's because the wind events have to continue to happen. If they just stop or we start getting the easterly trade winds starting to surge back in there, it will help cool things down and abort the event. But right now, it really we see a lot of seeds here. I should add, the models are jumping all over this. Let me show you a plot. This is a lot, especially if you're not familiar with El Nino, La Nina, Pedro. I don't know if I'm going into too much detail here, but
No,
if you see, so basically these different lines are different model runs. And if you're above this horizontal line here, and this is 0.5 degrees C, which is our threshold in Nino 3.4 index, if you get above that, you're considered in an El Nino event. And the stronger the values get, the stronger the event is. And so this is one of our objective tools. We consider lots of tools when we make our forecast, but this is one of them from North America Multi-Model Ensemble. And what you can see is it's expecting a transition very imminently, like May, June, July average. And then the peak intensity is somewhere around 1.5, if not a little bit more. And look at the objective probabilities that come out of that, right? These are huge. This is like 93% in May, June, July, going all the way 97%. Now, the team forecast is more conservative. Our forecast looks more like, let me see here. I want to close that. Where am I? Here we go. So this is our update. And our official probabilities are here. And so what you can see is we're peaking out about 85%. If you were to look at the ensemble mean of the forecast team, it's probably peaks around 1.2 degrees C. So a moderate event, not necessarily a strong one, but because the spread of potential outcomes is large enough, that means there's still pretty high chances, 4 in 10 chance that we could get a strong event based on our official forecast. There's still a 1 in 10 chance in the winter that we're still neutral, and this is a 2014 like bust. So just be mindful of that, and I'll go ahead, Pedro, and throw it back to you. Any thoughts and questions from all that?
No, I think the important thing in this story, based on the research, is that we need this, especially this time of the year when we are in the unpredictable part of the system, which has been traditionally called the spring predictability barrier. And to me, my interpretation is that essentially is when the system is too noisy and uncoupled. So the equatorial Pacific, well, the El Nino is an ocean atmosphere coupled phenomenon, and it is more strongly coupled towards the end of summer, of boreal summer in the northern hemisphere. So by August, by July, the Pacific cold tongue develops, and that increases the coupling, which what we call the Bjorn's feedback. So until then, all these westerly wind bursts can warm up the system and can try to excite feedbacks, but the feedbacks are not that strong. So we're in that state that, yes, it's important for an El Nino to happen. We need to have this sustained sequence of westerly wind bursts in this time of the year. And by the time the feedbacks get stronger, there's a perturbation large enough to really kick a big El Nino. So I think the conditions are probably, I would argue, that already starting to look different from 2014, because in 2014, which is what we're trying to, right here, we're trying to hedge against, because we don't want to make a bad forecast, or we don't want to prepare for neutral, and then we have a big El Nino. I think that's probably the biggest risk that everyone that uses information is trying to mitigate. So, I mean, we're already having a second westerly wind burst. I mean, like Michelle was saying, which in 2014 we didn't. We had a big westerly wind burst early on, and then we didn't have any westerly wind burst.
It was like turned off the switch there. Yep.
And we still don't know why that happened that year. Probably the southern hemisphere was too cold, and the trade winds re-intensify, and I actually don't know if we have a consensus on why the 2014 El Nino did not happen, or the forecasts were so uncertain.
Yeah, people are a little uncomfortable with it, but we there's irreducible components here that we'll never fully understand. Even if you were to perfectly observe everything, which we're never going to, like, our theories are still incomplete, and there's a certain amount of chaos that's already built into the system. That means that you'll never be able to get those 100% probabilities later in the year with a April forecast. So part of it is, it's interesting from my perspective, because we deal a lot with probabilities, and I don't think people, so there's kind of a core of people who think, oh, I have to make deterministic decision. You need to give me a yes or no. And we're like, well, we can give you an 80% chance, but that's not 100. And part of it is also, I think, some of those users can get frustrated because they're like, well, we have to make a binary decision. And you're just trying to hide behind your probabilities. Like you just never want to be, wrong. And I'm like, no, that's not quite it. Probabilities for us have meaning that, because people are like, well, how would you ever grade them? Because you could always be, you never be right, you never be wrong. How do you grade them? And I'm like, you can grade probabilities. If you say there's an 8 in 10 chance of something happening, that means every time you're in the situation, you make a forecast, 8 of those 10 times that outcome should happen. All right. That also means implicitly that 2 out of those 10 times it will not happen. We're literally making a forecast that 2 of those 10 times it's definitely not going to form. And we can go back to our past forecast and basically count how many times we were in the right category and not. And if we're making a reliable forecast, then that 8 in 10 times should show up, and 2 in 10 times it should not. If we're actually 100% correct, then our probabilities aren't reliable. So it is hard to convey that, but what we're saying here is we want it to be wrong 2 in 10 times.
Yeah, but I want to add something, because I don't know if you know this, but my brother is a farmer in Argentina, and there's a big teleconnection, which is these atmospheric pathways in which the tropical Pacific, everyone might be wondering, if you're not an expert, how is the equatorial Pacific or the tropical Pacific influencing the Americas or the Western Hemisphere? But so where I'm from in Argentina, there's a big teleconnection from the equatorial Pacific, this atmospheric influence. And so I talk a lot about actual users, about these forecasts, the individual, right? The little guy,
Right.
or the little girl. And the way I think this probabilistic forecast is also, how do you rule out the very catastrophic events? So maybe we can see the plumes that Michelle was just showing, which we can always, but probably the ones in the report, we should take them more seriously, because those are a consensus of different sources of information, not just dynamical models. Everyone should remember that, we're still doing research on these models and the theories of ENSO, but we should see those plumes, those outcomes, as maybe as ways of ruling out the very catastrophic events, like, are we going to have a big La Nina next December? And we could probably safely rule that
we have a 1% chance of a La Nina.
Okay, so right, 1%. I think we're all used to those dealing with that type of extreme probabilities. That's probably good news, right? These 3-year La Nina had massive impacts throughout the world, and a lot of people are tired of it. Really,
they're suffering in some areas.
And so, in a sense, the probability maybe can be used that way, or to remind everyone that the chances of an extreme El Nino, a 1997 type of El Nino, are still low today, right? Everyone is concerned about global mean temperatures because the planet warms up a few tenths of a degree every time there's an El Nino, and will that push us through some threshold with ongoing anthropogenic warming that cause some irreversible climate responses together with global warming? Corals are very vulnerable. We've been pushing corals to the limit with the warming in the equatorial Pacific. So every El Niño event, these vulnerable ecosystems are more threatened. I'm sure some of you
it loads the dice.
So we're still on that phase of, I think, of this the year in which looks like some sort of El Nino will happen. We still don't know how big, and we still have that chance of neutral, and we might not go back to La Nina, which is, to me, is probably the useful part, because La Nina again.
So as you know, like, they've been suffering multi-year drought in parts of South America because of the 3 year back-to-back La Nina. It's been terrible down there. So, it's funny when we talk about El Nino, La Nina, I know like the media will focus on a lot of the adverse consequences, but in this case, an El Nino forecast might actually help maybe push them out of that drought pattern, which would be very beneficial to them, provided it's not flooding rains. But anyway, certainly, there can be some benefits in parts of the world from this particular forecast.
Yeah, excellent. So maybe we should talk more about how we do. How do you your job, Michelle? Sounds like you need to consider all sources of information to create these updates. So could you tell us more about how these updates are made? What we just discussed, how you compile all this information. I mean, what the report that was released, that is released every month. What is it? The second Thursday.
Yes, second Thursday of every month. Good job.
Could you tell us more? How do you, it sounds like herding cats.
That's exactly what I was going to say. I'm basically a glorified cat herder. It's very exciting. But yeah, I think it's important to realize that scientists have tools, but we have lots of them. And we hear from the community, we hear from the researchers, we hear from other operational agencies. Like there's a lot of information out there. And even as scientists, it can be a struggle sometimes to assimilate that information. In fact, the path that we take is our perspective on assimilating that information, but there's different approaches and there's always ways to improve. So the way we do it at NOAA Climate Prediction Center is that there is a team. There are 11 members. I am one. And we're all equally weighted. And ultimately, I'm a very consensus-driven person. I rely on them to give me the probabilities and also make the assessments on whether we're in El Niños and La Niñas. So we have an ENSO alert system, meaning that like today we issued an El Nino watch, and that meant conditions are favorable for the coming 6 months for the development of El Nino. And that requires a certain level of consensus. And so each forecaster, in fact, we discuss all the analysis. We do that in a group. But when it comes down to actually making a forecast, I'm a big believer in folks doing it individually, because I don't actually want team members sit there and pressure each other. Like, why did you put that number? Like I want everyone just, we all look at some of the same data and the analysis and get more or less on the same page with regards to what's happening. But when push comes to shove and you have to put down a number, I want that to be independent. And then I basically take each of those 11 forecasts and I combine them. There's different ways to combine them. I have a certain strategy I use. And so the majority of the team has to favor the category. And we also have to be, basically in excess of 50%, a little arbitrary. But that's the threshold we've chosen. And when that is met, we issue the watch. So in this case, this past month, we were all on the same page. Every single spreadsheet was in support of a watch. We actually had this discussion last month and month prior, and we almost issued a watch then, but narrowly missed. So, now, we're a little bit more confident that potentially this El Nino is going to form. The other category that we'll be talking about here, especially if one were to form in the next couple months, is an advisory. So an advisory means that an event has formed, it is here. And that's tricky too, because ENSO, El Nino Southern Oscillation, is a climate phenomenon. And usually you need 3-month or seasonal averages to really start seeing where you're going with it. However, I work in an operational agency where we're mandated to update monthly. So this is a little bit for ENSO scary because it's a short time scale. And sometimes when you're working up to the moment in real time, it's not so easy to see what the ultimate 3-month averages are going to be. So we have somewhat strict criteria in that instance because we're working with month-to-month updates. So we require a monthly value Niño 3.4 to be in excess of our thresholds. So for El Nino, it needs to be in excess of 0.5 degrees C in the East Central Pacific. We also require, and the team has to sit down and determine this, that we have an overlying tropical atmospheric pattern that is consistent with El Nino, because there have been times in the past where the ocean has warmed, but as Pedro pointed out, it's a coupled phenomenon. You need to see changes in tropical rainfall, you need changes in the wind pattern, you need to see the overturning circulation, which is called the Walker circulation, to start pivoting and basically reacting to the ocean. There needs to be like some synergy or dancing between the two. So we're looking for that on a monthly basis as well. And then finally, there's actually 3 criteria. It's not even enough to have coupling on a monthly basis. We also have to have a forecast that shows that it's going to persist, because we want it to not last one season. We want to actually have it last at least 5 overlapping seasons. And when all that criteria is met, that's when we declare an advisory and say El Nino's here. So that's what the team's going to be considering coming up here. And it will be a tough situation. There are times where we do disagree, and I think that's healthy and signs that, we're taking into account diverse perspectives. If we're always in agreement all the time, then I don't know why I have a team. It's a good question.
Yeah. I actually didn't know that those were the 3 criteria. I feel like it's the way, probably not everyone knows, but I'm part of an email list that provides feedback to Michelle every month. And it's very stimulating because it forces us, the research community, to also think about what's going on, and also to have our own conversations, which it's quite enjoyable, and pushes to, researchers, sometimes we like to say all the things we know, but a forecast it's where the rubber meets the road. You really need to commit to an outcome, or a realistic outcome. And I mean, this reminds me of when I wrote my prediction of La Nina paper, which I really enjoyed all that year because it was an actual forecast. It was an experimental one, but it is a completely different mindset when you're doing research than when you are producing information that everyone else is waiting to use it to make decisions. So I actually was thinking, it seems like the way you produce these reports and these updates are consensus based. So how do you incorporate new ideas or new research ideas into these informations, things that maybe have not been tested extensively because they still haven't made it to a forecast or to all the operational forecasts, and it sounds like you've been quite a long time at this job, so you probably have seen this, like there's a new idea, and how do you do that?
So it's an excellent question. So part of my job is kind of to stay updated on what you guys are doing. And so every now and then I'll sit down and I'll basically go through a pile of abstracts and just to try and stay informed on the latest research and what's being said out there. And so part of it is, keep in mind, we have this team, and I, have my own skill set, but there's others on the team who are oceanographers. We have modelers. We have people who are just strong diagnosticians and statisticians. So having all of that is really powerful when we sit down and make a team forecast. So it's not just me, it's also the influence and the interactions and networks of the team members. So, to the first order, just contact us. There's enough of us that if you are interested in us seeing your work, send us an email. Happy to engage. So, there are also more formal procedures in NOAA where I work. There is a lot of modeling. We have at NOAA 2 seasonal climate models. One is the climate forecast system that comes out of where I work, the National Centers for Environmental Prediction. And then we also have Geophysical Fluid Dynamics Laboratory with their SPEAR model. And those two models are part of the North America Multi-Model Ensemble, or NME. And so this is an important component. So the one thing that can be done is just improving those model processes. And there are grant programs that the Office of Atmospheric Research run, the Weather Program Office, and also the Climate Program Office. If you're interested, reach out to them and say, hey, I have an idea for your models that you should consider. And there are grant programs and processes to try and influence that. I personally have benefited a lot through the years with collaboration from the International Research Institute of Columbia University. Mike Tippett is one of my most valuable colleagues. We've collaborated quite, through the years, and he's one of those people who's genuinely interested in improving forecasts and always has a new idea to try. And we've had applications come out of just very useful, brainstorming sessions with him. So, I'm always up to hearing new ideas, and I know my team members are also really enthusiastic about that too. So just reach out to us.
Excellent. Yeah, there's, I think, a lot left to be learned about the ENSO phenomenon. I mean, each of these events has revealed us something about it, and sometimes we probably need to wait until having a few realizations of those cases. I mean, this year could be maybe another realization of 2014,
yeah,
or another realization of 2015, and we have to wait a few more years until this system reveals something new.
Yeah. And that's fun, right? I mean, like we want, especially in my shoes, I want the forecast to be right, to be clear, 80% chance. I want the El Nino to happen. But I also, the scientist side of me is like, it's very excited when it doesn't go the right way, because we are probably going to learn a little bit from that. Even if it's not scientific, maybe we learn a little bit more about communication and how to apply it. I really think that every major event is a learning and growing experience for the ENSO research community and also forecasters. And so I really see them as opportunities. And as stressful as it is to make a forecast right now, and to be clear, the funny thing is that list that you're on, where we talk about the forecast, I always feel like when it gets really tricky, no one wants to contribute because they don't want to be on record for being wrong or something. And those are the times where I'm like, well, I don't want to make a forecast either, but we have to. We can't bypass it.
Maybe you should use the silences as a measure of.
Yeah. Yeah. There was crickets, so the uncertainty must be really large right now. Yeah, no, that's a great idea. But ultimately, I think we really do benefit a lot from these situations, and this year will be interesting and exciting in its own right, because even if it does decide to go, then I know what the questions going to be like. Well, what did you see here that's different from 2014? What about this particular instance made you more confident? So either way it goes, we're going to learn and grow from this.
That's a great project for a social scientist right there, to study those emails and see.
Yeah. Who is this guy?
How researchers contribute knowledge.
Yeah.
We usually say things when we're sure, not when we're not sure.
Yeah. Well, Pedro, I give you credit. You weigh in a lot, and that means that you're putting yourself out there, and I respect that.
Well,
it's hard to make forecasts.
Maybe this goes for anyone that in the group that is younger. I started being in this group a long time ago when I was in Miami, I think. That's why I'm there, because I was working at a NOAA lab. So it's been more than 10 years. And at the beginning, I was just listening and reading. I didn't say anything for years.
Oh, it's horrifying.
Yeah. But And it's a good experience to go through that process. Yeah, it took me a decade to be maybe a vocal member of that. I mean, to go from a silent member to a vocal member, and that's about what it takes to probably become an expert and be comfortable making statements about something.
Yeah, and part of it is getting used to failure, right? I mean, like, in other words, and we've been doing this, or I've been doing this for about 15 years. Like, I've had my failures and, I survived them, right? So part of it is just putting yourself out there. And even if it doesn't go the way you expect, you try and learn from that. And I think as humans, we also tend to be very fatalistic. We're like, when we fail, it's going to be the end of our careers. And I mean, maybe it is on occasion, but rarely not. I mean, like it's or usually not. It's usually in your head more than anything. And so you have to learn to get comfortable putting yourself out there.
I think so, but I think also our knowledge of ENSO has changed so much in the last. I mean, I've been around only 15 years in this field. But, I think 15 years ago, we probably thought it was a lot more deterministic, and now we realize it's a lot more stochastic. And so the kind of statements that we probably heard 10 years ago about it's coming for sure. Well, now we know. Yeah, for sure. Probably in August we can make a statement like that, but not. But this is not the time to be so confident. But still, use the uncertainty in a. I mean, this is information, and it's useful the way it is, even though it's probabilistic. We probably have to learn how to use it, and maybe help everyone that needs or wants to use this information learn how to use it. I think that's probably the challenge for the academic community, is how we, as we're more concerned about the climate, how we learn how to use these forecasts.
Yeah. Well, and you guys,
I have a question from the chat.
Oh boy, yeah.
Olivas, hi Kevin, is asking, has there been a time when an ENSO advisory was made, but we didn't see an El Nino develop? I think it's a great question.
That's a great question.
Thank you, Kevin.
So we've only had the watch advisory system in place since, I think, like 2012. So not even 10 years. So an advisory means an event's here. And then so what you're suggesting is that we say it's here on that monthly basis, and then it all crumbles and falls apart. That's my nightmare, by the way. That does keep me up at night sometimes. But at this point, no. Actually, we tend to gravitate the other way, which is, like 2014, 15 is a great example where we had to watch up the whole year because of the potential developments, but it stayed warm. Even that following winter, it wasn't like we saw cool conditions. It was still borderline warm. It just wasn't coupling. And so in that scenario, we definitely had to like kind of overcome and sort of stick. There was enough there in that situation that we wanted to continue the watch, and there was still the growth and the potential. And then sure enough, in early 2015, it finally took off, and that was early in the year. So we were what I'm saying is we were kind of busting on the watch. We kept saying it's coming, and then it finally did come. But no, we haven't had the opposite scenario where there was an advisory and then it fell apart. That hasn't happened yet. I think part of that might be the risk aversion from the team. We want to be pretty confident that we have all three of those things. So 2014, 15, we had warm ocean. So we had one of the criteria. We even had a forecast that suggested it would persist, and we weren't declaring it because we didn't see the coupling. And if you look at the rainfall, winds, whatever, it wasn't there. So it could have been easily the case that we said it's here, and then it never really coupled and materialized.
I think that's a great point. I mean, it's one I think about when I'm contributing to the discussion, is do we see the coupling? That's when we
Yeah.
know it's gonna feed onto itself and
Right.
sustain.
Yeah, we can't just see the ocean. We gotta see all of it, and that makes sense, especially if you are talking about. So one of the reasons people care about ENSO is that we want to see the teleconnections and the shifts in the patterns outside of the tropics. It's not enough that it just sits there in the tropics. Like for an island in the tropical Pacific, it may be meaningful to have just warm ocean conditions. But if you're talking about, North America, it's not enough. You also have to have the rainfall shift over, because then that influences the depth stream of the North Pacific Ocean, which can modify the pattern of ridges and troughs that occurs over North America and brings us impacts. So if we don't see that coupling and that feedback between the ocean and atmosphere, we're not going to see the corresponding teleconnections. And so for us, as forecasters, it's really important and meaningful to have that.
Excellent. I have so many more questions to ask you, Michelle, but I think we should wrap up.
Yeah, I got a hard stop at 2, so that's good.
And thanks everyone for joining. Thank you, Michelle, for joining. I'm probably will invite you to come back maybe by the time we should see the coupling or not. So maybe late July, August, maybe for the second Thursday of August, when we will know for sure what's going on.
Oh yeah, we might know sooner. Yeah.
One way or the other. Maybe second Thursday of July. We'll do this again if you want. And
yeah, no, I'm happy to try this again. Yeah.
We can continue discussing these topics. And thanks everyone for joining. Keep sending questions on the chat. This stream is going to be online for everyone to watch. Again, thanks again, Michelle.
Yeah, no problem. If people do have questions, you can just email me or something, and I can try and go back and help respond to them.
Excellent. And stay tuned. I think it's going to be an exciting year for everyone that cares